Welcome our student in the pharmacognosy course, and we are going to talk about isolation of alkaloids from Cinchona genus, the bark. Before we start, I will just very briefly give an introduction about natural products. And in very simple way, natural products are chemical compounds or substances created by living organism. And it can be a plant, it can be insects, it can be marine, etc. So any compound come from natural living organism, we call it natural products. And here it shows to you what is the importance of natural products. According to US Food and Drug Administration, they said that between 1981 and 2002, about 28% of new drugs comes from natural products. So it means it is really very important. Additionally, in another paper, it says that natural products started a very long time ago. Since the Egyptian papyrus, it mentioned that about 700 drugs, mostly from Egyptian plants origin, were recorded in the papyrus from 1500 BC. It means a very long time ago. And if we look to this slide, it showed you how you can get a great diversity of structures from nature. Very simple compound as anti-cancer, while Taxol is very complicated structure, and they both have anti-cancer activity. And additionally, this comes from a tree, while this comes from flower. Furthermore, this alkaloid compound as a neuroactive compound comes from frog, while this compound as anti-cancer comes from marine spongy. So you can see the diversity of structures, of diversity of activity from different natural origin sources. Finally, I will give you another approval why natural products are so important. In 2015, this lady with the Japanese, they got Nobel Prize in medicine. Why? Because they isolated and structurally elucidated bioactive compound, artemisinin from Artemisia. Accordingly, they got the Nobel Prize. This makes really a new golden age of natural products drug discovery. So currently, the corona is very serious problem. So they would like to find a drug as well from natural products. If we go to our course, this slide, it shows you summary of the whole story of the alkaloids. How? We start from the plant material. This is the fresh plant material. And this is the bark. Then we start first step by extraction. So this is a system of extraction which we will fix together. Number 1, number 2, number 3. So we will take the plant material and put it here. Then we add the solvent and we let it to be refluxed. After that, we will take this solvent, included the extract, of course, and then we make evaporization using rotatory evaporator. After that, we will see the TLC together using thin layer chromatography. And finally, we take this extract and we do some spectroscopy like LC, MS, NMR, etc. in order to get the active alkaloids. And this. So from this flow chart, it shows you the whole story which we are going to do together, and I'm sure we will enjoy. Why? Because lab and science is fun and enjoyable. So if we will talk about definition, classification, isolation, function in the plant, and biological activity. What is the definition of alkaloid? Very simple. If you look to this compound, it contains nitrogen atom. So any naturally occurring compound contain one or more nitrogen atom, we call it alkaloid. It means the term of alkaloid, like alkali, is commonly used to specify the basic heterocyclic nitrogen atom. Sometimes, of course, it is heterocyclic. Sometimes you can find it in open chain. The first isolated alkaloid was nicotine. We all know about nicotine, which it is in the cigarette smoking. And it is discovered by a chemist long time ago. The term is first coined by a German pharmacist in 1819. What is the biological activity? Usually, the alkaloid have an active compound, and it is mainly stimulation, pain relief, local anesthesia. Also, it has different activity like antimicrobial, but mostly we are talking about this area. What about classification? In alkaloid, you can have it in different form, like pyridine alkaloid, piperidine, quinoline, isoquinoline, indole. So all of this is depending on the skeleton. Like this, for example, nicotine. We all know about it. You see, this is the basic skeleton of it. While this is quinine, which we are going to discuss in this species. So according to the skeleton, you can say the structure belongs to which subclass. Then we shouldn't forget about, since we talked about alkaloid, that it makes stimulation, pain relief, addiction, etc. We shouldn't forget about codeine, for example. It is important, or morphine. It's important to use it after big surgical operation, but we have to be very careful also that it can make addiction. Also, mescaline, which it makes hallucination. What about the function in the plant? Is it important? Yes, it is really very important in plant as well. Why? Because it makes protection of the plant against insects. It is source of nitrogen. Accordingly, it is growth regulator, and it is source of energy. It's about more than 3,000 different types of alkaloids have been identified in more than 4,000 plant species. If you go to this compound, to this species, this is a fresh material, and this is the bark after drying, and it is a genus of the family Rubiaceae, which at least 23 species of tree and shrubs. What is the most common isolated compound? As I told you, it is, now you can know, this is quinoline structure. So it contains these 4 compounds. 2 compounds here, while R one time is H, another time is methoxy. The second one is the same, R is H or methoxy. This is quinine, while this is iso. What about the pharmacological use? It has also, it affects the muscles and resistant to malaria as well. So it is really very important as a biologically active or pharmaceutical use. Now it comes to the safety instructions in the lab. In case of fire, which I really don't hope so, if we need to leave, then you must go to the left to meet outside the library. If you need to leave BMC, go to the right side. We have 2 safety stations with eyes as well, showers, fire, etc. There is an emergency phone call, which I hope we don't need it. Then, I know you follow the instructions very well, so please kindly be careful to put the glasses and in this blue box. Also, always wear glasses to work in the lab. Coat, this is very important. Don't eat, please, kindly, or drink anything in the lab, not good for your healthy. The most dangerous chemical compound is DCM because it is volatile. The boiling point is about 40. So always transport it with a cover. I would be very happy if you keep your private phone silent. Finally, please feel free to take a break, but kindly let us know if you do that. What about the isolation procedure? We take it in more details. The first, after evaporization, we will make redissolving, then we will do solid phase extraction together, thin layer chromatography, and high performance liquid chromatography. So this is a kind of separation, while this is kind of identification. So we use chromatography further by next step will be spectroscopy. How to prepare the cortex? It is very easy. We will take 20 ml of water to 1.25 of chalk, calcium oxide, in a mortar and ground it for 5 minutes. After that, add 10 ml, 2% sodium hydroxide, then 10 grams of grind plant material, and put it overnight to be dry. So this is the preparation of the material. After that, we start the extraction. So we take the plant material here, the dark bark, and we add 200 ml of dichloromethane, DCM, with isoxalate. So this is isoxalate extraction. And we control the temperature at 90 degrees for about 90 minutes. After we finish the extraction, we would like to get rid of the solvent. So the solvent to help you in the extraction. And how to get rid of the solvent? By evaporization. So the solvent is then evaporated in rotatory evaporator. Then redissolve the extract in 5 ml of 0.1 sulfuric acid, then scrap the inside round bottomed flask for 5 minutes to get sample. Use long pipette to get extract. There is some kind of attention before running. Cooling is okay, the vacuum suction is okay, be careful, and round bottomed, etc. Then it comes to the first step of purification. We will take the easiest and quick way for purification using solid phase extraction, SPE. So this is the SPE column. Then we take the weight of 4 glass tube. After we have this one, it should be equilibrated, of course, first with sulfuric acid. Then you have to prepare these 4 solvents. Then apply the sample. Then 2 ml sulfuric acid, 2 ml water, 2 ml ethanol, and finally DCM. Now it comes to the step of chromatography, but it gives also some kind of identification. We take TLC plate and we put by a pencil, like a spot, like this way. Then we take with micro caps, we take very little amount of each fraction and the reference solution as well, containing a quinine compound to see if we have quinine or not on silica gel plate. And this is our element system, DCM diethylamine. Then we will check the results by UV at 254 and 366. I will just remind you quickly about chromatography of this TLC. We call this stationary phase. So the TLC plate itself called the stationary phase. And the solvent, this one we call it mobile phase. So after you put your compound and the reference on the stationary phase, then we put the plate in the jar and we let it eluted. Then we identify by the UV light. After elution and you examine it under UV light, this is just to give you brief idea what means TLC, which is thin layer chromatogram. If you have this spot comes from this compound, And you have this one. We call this RF value. What means RF value? The distance moved by a compound divided by the whole distance, we call it RF for this compound B. Similarly, for example, compound A, if you measure this distance by a ruler from here until here, divided by the whole distance moved by solvent, then we call it RF value. So this is a technique of thin layer chromatography. It explained to you in more details what I have said regarding the solvent. So you put the solvent until here in a chamber or a jar, then you let it eluted until here, then you let it dry and you examine under UV light. Attention please. Apply the sample, then place the TLC on refractory surface and blow the plate for about 15-20 seconds to dry. Let it dry first. Why? Otherwise you will smell DCM, which is not good for you. Don't let mobile phase to reach the top of the location to go to the front. So be careful and follow it. Finally, mix the contents of the tubes before applying onto the plate. Then we come to, so we have been studying TLC, which is very cheap, very old-fashioned, but still is effective. Now we use modern technique, which is HPLC, and from the name, high performance liquid chromatography. So liquid chromatography, this is TLC is liquid chromatography, but here is high performance. High performance means it is very strong, capable, and this is the apparatus. So this everything is automatically. In TLC you do everything manually, but in HPLC you just prepare the element system, you use the stationary phase, the flow rate, then make the method in the HPLC with all the parameters and let it eluted, and then you will get the chromatogram automatically. So it is the same idea of TLC. That's why we explain you TLC and you do it by yourself and you make the detection by yourself. But in HPLC, you get the chromatogram with all detections. I hope you had been enjoying my lecture, and I will guide you and help you of the lab. I'm sure we will enjoy together and we will understand it very well. Thank you very much for your kind attention.